Is it working? It's not working. Okay. I could hear myself. I don't know if anyone else did it. I'm always talking to myself anyway. So I hope a little bit of what I said was captured. The point I want to make here is that unless people feel confident and safe in their use of the internet, they will tend not to want to use it for commerce. And what better place than Hong Kong to emphasize the importance and value of using the internet as a tool for electronic transactions. But in order to do that, we need to cope with many of the problems that I've listed up there. I'm going to go a little further here. Some of the reasons that we have these security weaknesses in the internet are a consequence of operating systems that can be readily penetrated, or browsers which download files from home pages and then become infected because of the execution of JavaScript or Java or other high-level languages that install viruses or worms or Trojan horses or other kinds of malware on the hosting operating system. We also don't do a very good job of access control. We don't do a good job of picking passwords. We don't use two-factor authentication. That's changing, but we as users are going to have to accept that our choices of passwords are not very acceptable. Some people use the word password as the password because it's easy to remember. But unfortunately, that everyone else might know that too, and so it doesn't give very good access control. We need to change people's attitudes about the inconvenience of assuring better security. But in fact, we need it or we won't be able to protect them against themselves. Another major problem is configuration. Configuring things wrongly is really easy. Understanding that you have misconfigured something that might have major consequences is hard. And it's especially hard if you want a piece of software to tell you that you've made a mistake in configuring a system, a router, an operating system, or your own computer. This is a subject of deep research. We don't have good solutions for automatically detecting bad configurations. We might be able to detect the consequences of a bad configuration. And it's actually embarrassing that some of the worst misconfiguration events cause the largest problems in the internet, like misrouting and black holing and things of that sort. We also run into the problem that if we are not good about protecting our machines, they become invaded, they become hosts for worms and viruses or Trojan horses, and then they become part of what we call botnets, robot networks, that are used as resources by other people to generate spam, to generate denial of service attacks. It's actually a line of business for people. For a while, I was afraid that the botnets would be used to simply destroy the internet. But now it's clear that there's a business model behind the botnet herders. They don't want to destroy the internet. It's a way of generating revenue. So they would like to protect it. And in fact, they even go so far as to protect their captured computers. So some machines that have become part of a botnet have code in them to defend against the other botnet generals that are trying to get access to the machines. So it occurs to me that if some smart people among us could invent a good botnet that would protect all of us from all the bad botnets that are out there. So we have to know which botnet to join in order to be on the good guy side. To make matters worse, the process of abuse has extended now from simple hacking, possibly just to show that you could do it, to organized crime and other kinds of organized abuses of the internet. There are huge numbers of policy implications that are international in scope about trying to defend against these various bad practices. I don't have time to review those today, but I want to emphasize that the solutions to these problems are not entirely technical, and the solutions will require international cooperation. Once again, that word cooperation and collaboration being a key part of internet success. Speaking of collaboration, There's another phenomenon in 2011 which has been brewing for several years, and that's cloud computing. It's a buzzword. It's not a well-defined term. There are many different clouds that are offered by many companies. Google uses clouds for its work, but Amazon and Microsoft and IBM and others are implementing cloud-based computing systems. The reason I put this slide up, however, is to emphasize that it is the interaction between clouds that is going to become very important. We are in 2011 where the internet was in 1973. There weren't computer networks in 1973. They were proprietary in their scope. IBM had systems network architecture. Digital Equipment Corporation had DECnet. Hewlett-Packard had something called DS. The proprietary machines could be linked together very effectively. Digital Equipment machines on DECnet, IBM machines on SNA, and Hewlett-Packard machines on DS. They just didn't talk to each other. The networks didn't even know that any other networks existed. And into that vacuum comes the TCP/IP work to create a language that would allow those different networks and the computers on them to interoperate. Here we are in 2011. We have very disparate cloud-based systems. They don't know how to talk to each other. They can talk to clients that are in our laptops and desktops and notebook machines, but they don't talk to each other. So to give you an example, most of the clouds don't know that any other clouds exist. They can't even refer to another cloud. There's no language for it. If I have information in cloud A and I want to move it to cloud B, I don't have any way to tell cloud A and cloud B to cooperate to move data. I don't know in what way they should talk to each other to move the data from one place to another. And if I have access control in cloud A to protect my information, that metadata needs to move to cloud B in order to perform the same protection. I don't have a vocabulary for saying how to move the data and how to interpret the data. I'm sure you can generate your own long list of things that clouds should be able to do together. But that's the task of this 21st century, second decade, is to figure out how to achieve that interconnection. There are other challenges in this digital age that we're in, and I don't have time to go through all of them. I do want to draw attention, as if enough hadn't already been drawn, to the treatment of intellectual property in a digital environment. We all understand that digital information is easy to replicate and it's easy to distribute. It's very clear that in an environment where the replication of physical objects is hard and therefore, let's say, somewhat easier to protect against, in the digital world is a very, very difficult problem. And in fact, the business model of controlling copies may turn out to be very, very hard to implement in this digital world. We have mechanisms for digital rights management. We have cryptography in order to protect information that needs to be accessible only to those with authorized access. But I think that it would not hurt for the legal community and the engineering community to sit down together. Maybe this is something that APAN and APRICOT could attempt to foster, to talk about the technology of the internet and the World Wide Web and how one could adapt the kinds of rules for intellectual property that serve the old environment, how to adapt that to this new world. It may be that we are simply trying to fit an old model into this very dramatically new, very different economically structured system. I want to finish this slide by mentioning that each piece of software that you use, each application that you use, often generates a complex digital file. This digital file might be a spreadsheet, it might be a presentation, a PowerPoint kind of presentation, it might be some other very complex object used for playing digital games. That complex file is not meaningful unless you have the application software to interpret it. So here's the long-term concern I have. Let's imagine that it's the year 3000, and you've just done a Google search, and you've turned up a 1997 PowerPoint file. So the question, and imagine you're running Windows 3000. So now the question is, does the Windows 3000 system know how to interpret a 1,000-year-old PowerPoint file? Now, before my friends at Microsoft think that this is a gratuitous dig, it is not. Even if we were using open source software, the idea that a piece of open source software could still interpret a 1,000-year-old file is still a big challenge. So what I'm worried about is that as time goes on and as software evolves, that we may not be able to interpret the bits of the files that we've created with some of these complex programs. It could be that a company that makes the program says, I can't support this program anymore, and I'm going to move on to something else, and it's not backwards compatible. Or they might say, this application used to work on this version of the operating system, but it doesn't work on a new version of the operating system. You can make up your own scenarios for some of these problems. There are intellectual property questions. What if the application has to be preserved, even if it's not supported anymore? It has to run on a particular version of the operating system, and maybe that operating system has to run on a certain class of hardware, which might not exist anymore. So what to do about preserving the bits that we create over time? We may have to emulate the hardware, get permission to keep running an older version of the operating system and the application that ran on top of it in a cloud environment in order to preserve the meaning of the bits that we're producing. If we don't find a way to do that, I'm afraid that in the year 2100, people will wonder about the beginnings of the 21st century. All of our information will be digital, but it won't be interpretable because the applications won't work anymore. And if you don't think this is a problem, I guarantee you it's already a problem. Some image formats, for example, are not properly treated with newer software because backward compatibility was just too painful to maintain. So this is a serious technical problem. It may also require some rethinking about who should have access to software after it's not supported anymore. You could ask, can clouds be helpful in maintaining access to older software? So I leave that to your imagination. I want to mention also that this, in terms of Internet's evolution, more and more devices are showing up on the net. In Europe, it's sometimes called the Internet of Things. There are an increasing number of Internet-enabled things on the net, things like refrigerators and picture frames, things that look like telephones, but they're voice-over IP devices. And then there's this guy with an Internet-enabled surfboard. And I guess he was sitting on the water on his surfboard thinking, you know, if I had a laptop in my surfboard, I could be surfing the internet while I'm waiting for the next wave. So he put a laptop in the surfboard and a Wi-Fi service on the rescue shack, and now he sells this as a product.